Okay, so this video is going to cover how to write an equation in slope-intercept form. We're going to work on 3 different examples. The first being how to write an equation from a graph. The next one will be how to write an equation when we're given a point and a slope. And then the last example will cover how to write an equation when given 2 points. So starting with this one here, this example here, we're asked to write the equation of the line in slope-intercept form, and all we're given is a graph. And our graph does have these 2 points labeled here. Okay, so let's notice that one of these points, 2, 0, actually is our x-intercept. It's where our line crosses the x-axis. And the point 0, 3 is the y-intercept. So that's where our line crosses the y-axis. So when we're putting an equation in slope-intercept form, right, first off, this is slope-intercept form. Y equals mx plus b. And we like slope-intercept form because it tells us what the slope is and what the y-intercept is. M is representative of the slope, and our y-intercept is represented by b. So when it comes to writing an equation, this is the form that we want our equation to be in, and the 2 things that we're needing to input into this equation is the slope and the y-intercept. So that y-intercept could be positive or negative just depending on where our line crosses the y-axis. So just because this plus is in the equation, that doesn't mean that always has to be a plus. If we had a y-intercept that crossed at a -3, then this would be a -3. So then, since we do have our y-intercept labeled on our graph, our line crosses the y-axis at a +3. So the first thing that we can put into our equation is this +3, since that is our y-intercept. The only other thing we would have to do is to figure out our slope, and we can do that 2 ways. We can either use our slope formula, y equals y2 minus y1, over x2 minus x1. We do have 2 points represented on the graph. So if we said that 0, 3 was x1, y1, and that 2, 0 was x2, y2, again, doesn't matter which one's number 1, which one's number 2, just go with it. So if I chose this, then y2 would be 0 minus y1, which is 3, over x2, which is 2, minus x1, which is 0. So 0 minus 3 gives us a -3, and 2 minus 0 is 2. So we do have a slope of a -3/2. We can also see that visually on the graph, because if I was the point 2, 0, and I wanted to get to the point 0, 3, all I would have to do is go up 3, 1, 2, 3, and over 2, 1, 2. So up 3, over 2. And notice that we are going up into the left, which is the negative direction. So up 3, over 2, up 3, over 2. That's another way that we can pick out what the slope is just by moving from a point to another point. So let's just finish filling in our equation. So y equals, we can now plug in m, because m is a -3/2. We plugged in our points into the slope formula and got that. X is part of our equation always, and our y-intercept was a +3. So y equals -3/2 x plus 3 would be our equation for this particular problem. Okay, so this next example has the same instructions. Write an equation in slope-intercept form. The only difference with this one is we're not given a graph. We're given that we have a point that cuts through to -3, and we're also given that the slope is equal to a -1/3. So remember, that's what m represents. M is always slope. So we're given a point and m. So slope-intercept form is y equals mx plus b. So we need to plug in for slope, and we also need to plug in for our y-intercept, which is what b is. So we're not given the y-intercept in this particular problem. We're not given a graph shown through it. This point is not a y-intercept, we know, because this x value is a 2. If this were a y-intercept, that x value would be a 0. It would be a 0 every time in order for it to be a y-intercept. So this point is not that. Now we are given the slope, that the slope is a negative 1/3. So that is something that we can go ahead and plug into our equation here. And remember, we're plugging it in for m. So far, our equation would look like y equals a negative 1/3 x plus b. And we're almost there. The only thing we have to do is figure out what is b. And the only way around that here is, well, we don't have a y-intercept. As stated, we don't have a visual. That point does not represent that. The only other thing we're given is that our line goes through the point 2, -3. But think about what that point represents. This point represents a coordinate on our graph. So it represents a point that is on our line. And a coordinate is made up of an x and a y value. Do notice we do have an x and a y value in our equation. So what we can do is we can actually plug in this point. We can plug in 2 for x and plug in -3 for y. It would look something like this. And what we're doing is we're plugging in for x and y, and what we're going to do is we're going to simplify this equation and solve for b. That way we can then take what b is and plug it into our equation where we need. So essentially to find the missing piece. So we plugged in 2 for x and we plugged in -3 for y. The next thing that we would do here is simplify this calculation. So I'm going to drop down the -3. A multiplying fraction straight across, -1 times 2 gives us a -2 over 3 times 1, which is a 3. The only thing left to do would be to add 2/3 to both sides of our equation, and we would have what b is. So over here off to the side, I'm going to take -3 and put it over 1. And what we're doing is we're adding 2/3. Now, in order to do that, we do need common denominators. Common denominators of 1 and 3 is 3. So what I'm going to do real quickly here is I'm going to convert this fraction. We know that 1 times 3 would give us 3. So I'm going to multiply by 3, top and bottom. -3 times 3 gives me a -9 over the 1 times 3 gives me that 3. So what I've done then is change -3 over 1 to -9/3. And I do this because we need common denominators in order to add fractions. Now that we have common denominators, we can add. -9 plus 2 is a -7 over our common denominator of 3. So that is what b is equal to. So after we did this calculation here, we got that -7/3 is equal to b. So all we have to do is plug that into our equation. So this is where we were at. We had plugged in our slope. So I'm just going to rewrite this equation. And the only thing we're doing is we now know what b is. B is a -7/3. So I'm going to plug in a -7/3 right over here. And this would be our equation to this line. This is going to be our third example on how to write an equation in slope-intercept form. In this particular example, we are given 2 points, and that's what we're given to write our equation. So once again, we're using slope-intercept form, and the 2 things that we need to plug into slope-intercept form is the slope and is the y-intercept. So we need to figure out, well, how can I find the slope and how can I find the y-intercept based off of this information? The easiest thing to go with first is actually to find the slope in this one here. We are given 2 points, and we can find the slope when we have 2 points by plugging it in to the slope formula, which says m equals y2 minus y1 over x2 minus x1. So I'm just going to take this point here, and I'm going to say that -3 is x1, and that 1 is y1. And the point 24 is going to then be x2, y2. And I'm just going to take these and I'm going to plug them into the equation here. So we would have y2 minus y1 over x2 minus x1. And then simplify our subtraction here. So on the numerator, 4 minus 1 gives us a 3. Over 2 minus -3, so that is our double negative rule. That is going to cancel to a positive, and 2 plus 3 is a 5. Therefore, our slope is 3/5. So I'm going to go ahead and plug that into our formula here. So instead of m, we have 3/5. Everything in the formulas is going to stay the same, which means that we are halfway there. The next thing that we do have to do is figure out what is b. Now again, we don't have a visual to where we can actually see what our y-intercept is. We're not told what our y-intercept, neither one of these points represents that. Remember, we would have to have a 0 as our x value in order for one of those points to be a y-intercept, and we do not have a 0 as an x value for either one of these. So what we're going to do at this point is actually what we did in the last example. We're going to take one of our points, which represents an x and a y, and we're going to plug that into the x and the y into our equation. So I'm going to choose the point 2, 4. No particular reason. I tend to like positive numbers better than negative numbers, so that's the only reason why I didn't choose -3, 1. You have the option to pick either one, but pick a point and plug in the x and y values into your equation. So that means since I picked 2, 4, that means I'm going to be plugging in the 2 for the x and the 4 for the y, which would look like this. I am going to write that 2 as a fraction just so I can go ahead and simplify the calculation with that slope there. I have the 3/5. My x was a 2, so I have to calculate 3/5 times 2. So numerator times numerator, 3 times 2 gives me a 6. Over the 5 times 1 is a 5. So in order to solve for b, I need to subtract that fraction on either side. And whatever I get when I do 4 minus 6/5 is going to be what b is. Okay, so we will be subtracting 4 minus that 6/5 and see what we get. So I'm going to go ahead and put that 4 over 1 since we are talking about subtracting fractions here, which means that we do need common denominators. Common denominators of 1 and 5 is a 5, which means I need to convert 4 over 1 to have a denominator of 5. I know that 1 times 5 would give me a 5, so I'm going to multiply top and bottom by 5. In the numerator, 4 times 5 gives me a 20. And the denominator, the 1 times 5 gives me the 5. So I have 20 over 5 and we're subtracting 6/5. So now that we have common denominators, we can subtract. 20 minus 6 is 14 over our common denominator. So that just means that 14 over 5 is what b is. I can go ahead and finish filling in to my equation. A little bit of space here. So this right over here was our working equation. We had plugged into the slope formula to get the 3/5 there. So the only thing we had to do was find b, which we did by subtracting those fractions. So we got that b is equal to a 14/5. So I'm just going to plug that into our equation here. So instead of plus b, I will be putting plus 14/5. And we have our completed equation. Y is equal to 3/5 x plus 14/5. And again, we found the slope by using the slope formula by plugging in these 2 points. And then we found our y-intercept by plugging in our x and y values along with the slope in order to solve b.